So we're going to work on Roman numerals today. It's actually pretty easy and a lot of fun. It still has Latin grammar in it, so don't worry, we'll get there. But I want to make sure you also have your student notes printed out. There's some things in there, some charts that if you fill them out while we're going through this together, then it's really easy as a reference to throw them in your notebook in the note section instead of having to go back to the appendix of your book all the time. All right, we use Arabic numerals. Arabic numerals look like this. They're the normal ones that you use in math. The other ones here are Roman numerals. The I, the V, the X, the L, the C, the D, and the M. Those are called Roman numerals. And one of the most interesting things about Roman numerals is they did not have the number 0. They figured if something wasn't there, it shouldn't be counted. So these Roman numerals date back to the shepherds who counted their flocks by marking notches on their staffs, right? You can't count 0 sheep, so no reason for a 0. Now, they didn't originally use the Roman letters that I just read to you, but just the notches. And this tally method used on sticks was used by people all the way up until the 19th century. So when counting their sheep, they would mark 4 notches. So you'd have 1, 2, 3, 4. And then on the 5th notch, they would cut a diagonal. Now, if we're going to count in groups of 5, we do 1, 2, 3, 4, 5, and we go all the way through, and it becomes a really easy way when you're counting something and trying to tally to go back and later count 5, 10, 15, or in groups of 10s, right? So instead of doing their mark all the way through diagonally, they would, for number 5, they would do this. Now, can you kind of see the similarities between how we got to the V? Right? So every 10th notch, so 6, 7, 8, 9, 10. So instead of making it look like a V, it was actually a strike through. So you can begin to see how it looks like the X there. I'm going to erase this to get this out of the way. Begins to look like the X. So every 10th V got an overlapping notch. So here we have 46, 47, 48, 49, and we would get a 50. So it would be 2 of those. And every 10th X got an extra overlapping notch. So we're going down to 96, 97, 98, 99. So we've got 100 there. And what's interesting is that I'm going to show you here. If you flip it a little, it begins to look like an L, doesn't it? And this one, if you begin to round it a little bit, it begins to look like a C. Okay, so let me show you the Roman numeral 8. So how the shepherds would have counted, we've got 1, 2, 3, 4, 5, 6, 7, 8. If you know anything about Roman numerals, you know this is the way modern times we write 8. So you can begin to see 6, 5, 6, 7, 8, and then a 5. You can see how this has in common. Well, when you look at the first one, your eyes skip past the first 3, go immediately to the V, and so you already know there's 5. You don't even have to count the 3 before, so you can understand why they shortened it, because they didn't need that. They already knew that the first V represented 5. They didn't need to count what's in front of it. Okay, so if a symbol appears to the left of a symbol of lower value, it should be added. I'll give you an example of that. So if we have a V, which is a 5, it's worth more than an I. We're going to add those two together. So if we add a 5 and a 5 and a 1, we get 6. If a symbol appears to the left of a symbol of higher value, it should be subtracted. So we've got IV. So the I appears to the left of the V, which is worth more. So we subtract it. We actually reverse it. So this is a 1. This is a 4. We don't take away 1 from 4. We don't take away 4 from 1. We take 1 away from 4. So you wouldn't write it like that. You'd write it 4 minus 1, or actually 5 minus 1. My apologies. I'm a Latin teacher, not a math teacher. 5. We'd actually write it 5 minus 1, which is 4. Okay. Let's try a couple of these together. So, VII, all the symbols are to the lower symbols are to the left, right? This is to the left of the symbols of lower value, so we're going to add these all together. V is 5, so V is 5. 1, I is 1, so plus I plus 1 equals 7. Same thing here. The symbol appears to the left of a symbol of lower value. So the lower value is on the right. So we are going to add together. We know x is 10. We know I is 1. So we have 11. All right, next one, same thing. The higher value is on the left. So we have L equals 50. V is 5. And that gives us 55. By the way, generally you can't add more than 3 of the same number of digits. So you could do 3 C's or 3. That's why we don't do 4 like this. That's why that's why instead of this, we turn it into the V. We do that instead, the 5 minus 1. Just so you know, it's 3. They generally said 3 of the same number or the same letter together. Okay, so let's do MCM. First one is M, that's by itself. There's nothing to the left of it, so we have 1,000. Okay, just like M is 1,000 right here. All right, so here these two are grouped together because we have a symbol of lower value on the left of a symbol of higher value. So that literally is 1,000 minus 100. I mean, really, with 100 comes first. Remember that we flip them, so that becomes 900. So 1,000 plus 900, you're always adding these groups together, equals 1,900. Okay, same with IB. I showed you that one. We're going to subtract it because the lower symbol is to the left, and so we have 5 minus 1 equals 4. XL, same thing. The higher one is on the right side. So we have if the lower one comes first, then you subtract. If the higher one comes first, then you add. That's probably the easiest way. Lower first, subtract, higher first, add. So we have 50, which is L, minus 10. Remember, you have to flip it because it looks like 10 minus 50 equals 40. And 1892, let's put these in the opposite. So the first we're going to deal with the thousands first, not the units first. So 1,000 is M. We're going to add to it. We got to get 800. How are we going to get 800? Well, the biggest we can do is a 5, so we've got 800. So I know that I've got a 500 that I can add. 500 right here, and I've got 3 C's, which is 100, and I can add 3 C's together. So we've got 500, so you've got an M, so you have a 500 I know I can add. 500 is D, and then we have C, 100, 200, 300. So that whole thing together is 800. And then we have to do the third one, which is 90. We can't add a 50 plus 4 X's, right? We can't do that. So we have to go to the next highest one, which is 100. So basically, to make 90, we have to do 100 minus 10. So if you remember, the smaller number comes to the left. So we have an X. We reverse it when we do it, and 100 is C. And then what we have left is a 2, and that's easy because when we know we can add 2 ones together. So plus 2, which equals 1, so we can do 2 I's together. So that is MD. So 1892 is MDCCCXCII. Now, if you have any problems with that, there's tons of stuff online if you've never done it. Tons of stuff to practice, tons of videos to watch, just so you know that it's really easy to find things. All right. So let's talk about cardinal numbers. And a cardinal number is any whole number that is 0 or greater. Okay. Numbers are out. So cardinal numbers come from the phrase cardinalis numeri. So the fact that it's called a cardinal, that comes right from Latin. It doesn't mean anything else than that in English. We just pull it right from there. It's a derivative. And numbers are adjectives because they answer the adjective question, how many? So they have to get treated like adjectives. Here comes the Latin grammar part. Now, you've already met the cardinal number adjective unus. It was one of the naughty 9. So this adjective is declined only in the singular, clearly, because one can only be singular. Likewise, Latin adjectives for 2 and 3 only decline in the plural. So this, if you remember how to decline, the only thing that's odd about this one, if you remember, is the genitive and the dative. Otherwise, it looks like a normal first and second declension noun. This is why it's naughty. In duo, you'll see it's kind of a mix of things that look like first and second declension, and you got the boosts here, the or room, more boosts. So you'll see kind of a mix of first, second, and third declension patterns. So you want to make sure that you get the video stopped and you get all of these down. So the pattern for trace 3 is identical for the pattern for third declension adjectives. So that one's a little bit easier. So go ahead and fill in your charts. Come on back. Here's a rule. The cardinal numbers from 4 to 100 are indeclinable, which means there is only one form of the number and there are not endings to memorize. So in the teen numbers, we use these to form prefixes to the word decim. And the word decim means 10. Decim is like when we use the suffix teen. So un decim is 11, duodecim is 12, tridecim is 13, quattuor decim is 14, quindecim, so on and so on. But if you take a look at these two, they don't quite follow the pattern, kind of like how 11 and 12 don't fit the teen pattern in English. And the word vigente, you see that right here, it means 20. So same here, vigente, you can imagine what the number 20 is, right? So 20. So duo day. So remember, it got duo, which means two, day, which means from, and vigente, which means 20. And of course, what is 2 from 20? 18. Same thing here. One, day, from, vigente. 1 from 20 is 19. So it's pretty logical in the way that does it. So Latin also has a suffix that is equal to the ty. See the ty in our language? And that suffix is ginta. So as in 20, 30, 40, etc. So you can see all these two. Vigente is 20, which we just talked about, right? Vigente is up there. Is 20. Triginta, quadrintka. So it's pretty easy to see how they just put the numbers together, just like we do in English. And after 100, most decline with first and second declension rules, and of course are only plural. So centum is 100. You can kind of see how century comes from there. And remember our C that represented 100 up here? Our C that represented 100, how it kind of looks like the C from the tally marks. It's all kind of cool watching how language evolves. So ducente, those numbers after they decline like first and second declension adjectives. Remember, it ends in the E, I, A because they can only be plural. So it's not ducentus aum. So think about that, why they're there. So 200, here's some examples. 500, 800. That should be it's pretty easy. I won't ask you to memorize them. You have a reference for all of these in the back of your book should you ever need them. Okay, let's talk about ordinal numbers. Last thing we're going to talk about today. So an ordinal number tells the position of something in a list. You can think ordinal is comes from the Latin word ordo, which means series or order. Order tells I'll even say tells the order or position of something in a list. So it's first, second, third, fourth, that kind of thing. Okay, so it declines. It declines like first and second declension adjectives, which is awesome because those are really easy. So in English, they're the words first, second, 10th, 78th, 423rd. In Latin, all ordinal numbers decline like first and second declension adjectives. And so as a result, they must match the nouns they modify. You should know this by now. In gender, case, and number. All right, I'll show you. There's 3 of them here. I'll show you how they work. It's pretty simple. They're also listed as a reference in the very back of the book. I'm not going to make you memorize them. So, Prima Femina. So, the prima means first. Femina means lady. Decimus, 10th. Miles is soldier. And sextus decimum scutum. So sextus decimum. Together, that makes 16th shield. I'll compare it to the word 16. Back up here. So 16 is se decim. Se decim. So it looks a little bit familiar, but not enough that you have to get them confused. That's it. That's all there is to Latin numbers with a little bit of grammar in there.